Hi everyone. Sorry for being late. I actually got a bit late. Yeah, there will be class today. Sorry about that. If there is no class, I'll get the stream or uncheck. But yeah, there will be class today. Again, thank you guys for joining. Let me just quickly check if the audio is. So yeah, I think audio is working. So today we'll be solving two problems again. The first problem we'll solve today is edit distance. Now the problem edit distance, what it tells is you are given two strings s and t. Return the minimum number of operations that are required to convert s to t, right? So we are given two strings s and t. We are asked what is the minimum number of operations that you will need to convert s to t. What are the operations that we can do? The operations we can do are insert a character at any position of the given string, remove a character from any character from the string, and replace any character from the string with any other character. So these are the three operations that we can perform. All right. Okay, so these are the three operations we can perform. So what is the minimum number of operations that is required to convert s to t? So for example, geek and gsec, right? So the output should be 1 for this, because why? We just need to insert one additional character s, right, in between e and e. So we can insert a character at any position, so we need minimum one operation. So similarly, gfg to gfg both are same, so we need 0 operations. So we are given edit distance and we have to solve this problem, right? And the size of both the strings are within 100. Okay, size of both the strings are within 100. So we have to find the minimum number of moves needed to convert one string into another string. So let's understand this, right? So let's say we have a string, any string, right? We don't care about what they are. Let's say we have two strings a and b, right? And we have to find the minimum number of moves needed to convert a into b. And we have three types of move, that is insert a character at any position, remove a character, and replace a character with any other character, right? These are the three moves that we have. So let's say a has the total number of characters in a, it is n. Total number of characters in b, it is m, right? So there are n characters in a. They can be anything. There are n characters in a. There are m characters in b. There are m characters in b. Okay. Choose any one of them, right? At any point of time, just choose that. Let's say it is at the nth character here. At any point of time, n can be anything, right? It can be here, 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 anywhere up or the end. Let's say at that point of time, at b, we are at the mth character. M can be, let's say, here. It can be here as well, anywhere, right? It doesn't matter like where m is or n is, right? So this is the state of the problem, that, and we'll define the recursive function. So again, like, we are asked to minimize what is the minimum number of moves needed, right? So this definitely looks like a dynamic programming problem. So the first thing that we'll do is we will find the state. Now how to find the state? So we are given two strings, right? We are given two strings. Assume that at one of the strings you are left with the first 10 characters. You have matched the remaining portion after this, like this portion that you have after this n, this portion, this is matched, and after m, this portion, this is matched, right? So you are left with first n characters of the first string and first m characters of the second string. So whenever you are given, like, you are given things like you are given two strings or you are given two arrays and you have to do something with them, a general trend of the states that you can take is, hey, I am having the first n elements of the first array and the first m elements of the second array, and that's a valid state, right? So again, like, it depends on the problem. It might be that the problem cannot support the constraint of n into m, n comma m, or the problem cannot actually, like, the problem can be solved in a different way. You need different states. It completely depends on the problem. But in our case, this looks like a promising state, right? So if n comma m, these are the states. So what does this mean? What does f n comma m mean? F n comma m will be the minimum number of minimum number of operations needed to convert first n characters of A to first m characters of B. Right? Okay, so with any dynamic programming problem, the first operation that we do is write this thing, identify the states and write a recursive function with the states and telling what does it exactly return. So what does f n comma m return? It returns the minimum number of operations needed to convert the first n characters of A to the first m characters of B. So first n characters of A, you take the first n characters of A, you want to find the minimum number of operations needed to convert the first n characters to the first m characters of B. So that is the first step of our solving a recursion problem, right, or a dynamic programming problem. So if n comma m is, you define it like this. Now this is actually halfway through, like you have already done half of the half work, right? The next half will be divided into two more steps. The second step is pretty simple. You just fix some values of this n and m. Let's call this something p comma q. F of p comma q. What is f of p comma q? So n equals to p, m equals to q. For n equals to p and m equals to q, you assume that you make an assumption. So what do you make? You make an assumption. You make an assumption that if pq doesn't return the value correctly yet, you make an assumption that if pq doesn't return the value correctly yet, that is for n equals to p, m equals to q, it doesn't return the value correctly yet, but for every other possible value of n comma m, it returns the value correctly. So if n equals to, let's assume n equals to p minus 1 or m equals to q minus 10, it will return the value correctly for this pair of n comma m, right? So for everything except n equals to p, n equals to q, or in fact n equals to p, m equals to q minus 1, for this pair also, this state also, it will return the value correctly. Anything but p comma q, it will not return the value correctly. So that is the assumption that we make. The third step will be computing fp comma q. So the third step will be computing fp comma q. Alright, and this will give us the recurrence relation. So third step is computing fp comma q. So what is fp comma q? So you have A, and let's say you have p characters in A, the first p characters of A, and the first q characters of B, right? So that is fp comma q. What is fp comma q? It will return the minimum number of operations needed to convert this first p characters of A into the first q characters of B, right? So right now, when you have made the assumption, you just want to compute fp q. So just think about the current state only, that is the pth character and the qth character. Just think about this only for now, right? What can happen with the pth character and the qth character? Two things can happen, right? Two things can happen. That is, A of p, the pth character, is not equals to b of q. The pth character is not equals to the qth character of b. And the second thing that can happen is it is equal. These are the two things that can happen between the pth and the qth character. So these are the two things that we'll do. Okay, now they are equal. They are equal means they can be matched. This character can be matched with this character. So we will just match it. Whenever it can be matched, we will just match it. So, and it is always to our best interest, right? We can definitely think that we don't want to match it. We don't want to match. Let's say there is a here and there or there is a m here and there is a m here as well. So we might think, you might think that, hey, I don't want to match this m with this m, rather I want to do some operation right now, and later on there might be some m here, and with this I will match this m. Anyways, the answer would not affect, right? If you match with this m also, for this m you will have to do that operation. So the answer is not actually affected. So whenever it is matching, whenever these two characters are same, just assume that you will match them. What does it mean that you will match them? Then you are left with p minus 1 characters of A and q minus 1 characters of B, and as you have made a match, you didn't do any operation, right? So it will be the same as f p minus 1 q minus 1. What is the minimum number of operations needed to convert the first p minus 1 characters of A to the first q minus 1 characters of B, and you are matching the pth and the qth character? So it will be the same count, right? The count will be same, so it will be equals to this. When it is not matching, that means, let's say the pth character here, it is not matching with the qth character, right? So let's rub these. Okay, so the pth character here is not matching with the qth character. Let's say there is a something here, x here, there is a y here, so these two are not matching. So what do you want to do? You want to do some operation here. So what are the operations that you can do? Definitely you have to match them. If you do, your task is to match these two things, right? These your task is to convert this string into this string, so you have to match this y to something of this B, right? So what are the things that you can do to match this y? First is, you can insert a character. Insert a character means you can match with this x, that is, you place a x here and you match with this x and then start searching for the y and the remaining part. You match this x with this x, the new character that you introduce, right? So first you can do is, you can insert a character. Insert a character, that means after you have done this, you are done doing one operation, plus what do you have left? You have left you are left with p characters of A, because you have not matched this y, rather you have inserted a x here and you have matched this x with this B's x, right? So these are matched. So, and how many characters of B are left? Q minus 1. So 1 plus f p comma q minus 1, what is the minimum number of characters needed to match the first p characters of A with the first q minus 1 characters of B? Right, so that is the cost, and plus 1 because you have added one operation for adding this x to A. So that is the first insert case. Second operation that you can do is delete. You can delete characters as well. When you delete a character, it means that you are removing this y. You are removing this y or this pth character completely. So you have not matched with this x yet, right? You have not matched with this x yet, rather you have just removed this y. So what are you left with? You are doing one operation, so cost, add a cost of 1, plus you are left with p minus 1 characters, p minus 1 characters of A, but you have to match with the q characters of B because this x is not matched here. So q characters of B, so that is delete. Right, so these are the two operations. The third operation is replace. Right? So in replace, what do? We are telling that there is y, there is x. Why not just replace this y with x and match them? We can do that. So replace, that is one cost is coming up. But what is left after this? You are left with p minus 1 characters of A and q minus 1 characters of B, because this y is replaced with x then, and they are matched. So you are left with that. So 1 plus f p minus 1 q minus 1. So these are the three things that you can do, and for this equal case you can only do one thing. So finally your recursion becomes, and what do you want? You want the minimum number of operations, right? So you want to minimize over them. So finally the recursion becomes if n comma m will be is equals to minimum of 1 plus, everything takes a cost of 1 plus minimum of f of n minus 1 comma m, f n comma m minus 1, f n minus 1 comma m minus 1. Minimum of these three. If a of n is not equals to b of m, otherwise f n minus 1 comma m minus 1, otherwise if they are equal. So this is the final recurrence relation, right? This is the final recurrence relation. Now talking about the base cases, let's just talk about the base cases. What is f0, 0? f0, 0 means You are left with 0 characters from the first string, you are left with 0 characters from the second string. What is the minimum number of operations to match? 0. So it is 0. What is f n comma 0? You are left with n characters of the first string. Let's say first string is f3 comma 0. So you have abc, let's say, in the first string, and the second string you have empty. It is empty. So what is the operations that you can do? You have to delete all of these abc. So it will be, total cost will be n. Similarly, f0 comma m, let's say you have empty string and you are matching with this abc. You have to convert this to abc. So you have to add a, b and c. So the cost will be m operations. So these are the base cases. These are the base cases. So final recursion is this thing, right? This is the final recursion with the base cases. Let's try to write the code for this now. Let me know if you have any doubts. Int n equals to s dot size. Int m equals to t dot size. Alright, so we have taken out the sizes. S equals to s dot size, t equals to t dot size, m equals to t dot size. Int dp will take n plus 1 comma m plus 1, so that we do not go for 0 based indexing, right? We'll go for 1 based indexing, so that 0 means it is empty string. We can write our base cases properly. So for int I equals to 1, I less than equal to n, I plus plus, dp I0 equals to I, and dp00 equals to 0. Dp I0 equals to I. This is the first base case. Second part will be for int I equals to 1, I less than equal to m, I plus plus, dp0i equals to I again. Finally, for int I equals to 1, I less than equal to n, I plus plus. We'll go through all the states. So for int j equals to 1, j less than equal to m, j plus plus. Now there are two cases, right? If s of I is not equals to t of j, if s of I is not equals to t of j, and else if s of I is equals to t of j. If they are equal, it's simple, we'll just directly write it dp ij equals to dp I minus 1, I minus 1, j minus 1. And for this, dp ij equals to 1 plus minimum of dp I minus 1 j, comma minimum of dp ij minus 1. I'm just writing the recursion, right? Whatever recursion we have derived, I minus 1, j minus 1. So this is the recursion that we have derived. And finally, what should be the answer? The answer should be return dp n comma m. N comma m, why? Because what is n comma m? The minimum number of operations needed to convert the first n characters of first string with the first m characters of second string. So that is the sizes. So total first string to second string, and that is what we want. So that's why we return that. Let's try to run this. So this is working. Let's try to submit. Oh, okay. We are getting a less output. That's interesting. PC. Oh, here we are comparing I and j. It should be I minus 1 and j minus 1. My bad. So now let's submit this, because we are assuming 1 based indexing, right? Yep. So this is working. This is working. I hope this is clear with everyone, and let me know if you have any doubts, right? So we'll move to the next problem. Again, it's a very popular question, or a classic question. The question is longest increasing subsequence, right? So the statement is pretty simple. You are given an array of integers. Find the length of the strictly longest increasing subsequence from the given array. So you are given an array of n integers. You have to find the length of the longest increasing subsequence, right? What is longest increasing subsequence? You choose a subsequence that is strictly increasing, right? So for example, n is 16 and this is the string. So longest increasing subsequence will be 0 2 6 9 13 15 of length 6. So 0, after that you choose 2, after that you choose 6, after that you choose 9, after that you choose 13 and 15, and this is indeed a increasing subsequence, right? This is indeed a increasing subsequence. What is a subsequence? A subsequence can be any subset of the array, right? Any subset of the array. But whenever we talk about subsequence and a property, like we are telling the subsequence should be increasing, that means it is a subset, but the order in which the elements are with respect to in the array, they should be increasing. That is, we can tell like this, that we can take 2 from here, after that we can take 4 from here, and that is also an increasing subset. But see, 2 is coming after 4, right? So in the subsequence, when we choose the subsequence, 2 should come after 4. So when we write them, we should write 4 and only then we should write 2. So it no longer remains an increasing subsequence, right? So that means in order they are there in the array, in that order we have to take them, and it should be increasing. So the value should be increasing. So 0 to 6, see, they are in the same order, right, in the array as well. 9, they are not consecutive, but they are in the same order. 13, 15. Right, so or we can choose 11 as well. Instead of 13, we can choose 11, but we cannot choose 11 and 13 together, because 13 is coming before 11, right? So that will not be an increasing subsequence anymore. So so the length will be 6. Similarly for this 5, 8, 3, 7, 9, 1, the length will be 3 maximum possible. That is 5, 7, 9. This is the increasing subsequence. 3, 7, 9. This is the increasing subsequence. 8, 7, 9. This is not an increasing subsequence, because 8 after that 7 is coming. So it is not an increasing subsequence. So we have to do this in n log n time, right? We have to do this in n log n time. Let's understand. Okay. So okay, what do we want? We want to find the longest increasing. So this is also called the LIS problem, longest increasing subsequence, right? We have to go for a DP solution. We are whenever it's like minimizing something, maximizing something, and you see that you cannot do a greedy solution, right? Here you cannot do a greedy solution, because if you start with a greedy solution, let's say you choose some value and you choose the lowest value here. Let's say you choose the lowest value here and start a greedy solution. Then let's say you choose 5, 5, 7, 9 will work, but let's say first value was 8 or something like that, or you choose the lowest value 1, then it will not work, right? The lowest value, choosing the lowest value and greedily doing it will not work. So whenever you have some tasks like number of ways, minimum value, maximum value, you have to maximize something, minimize something, find the number of ways, these things, right? Whenever that's there and you see that greedy is not possible, and definitely it's not a you have to be sure that it's not a mathematical problem or some other type of problem like brute force type problem. After that, what you should think about is a dynamic programming solution. It might be a DB solution, right? So again, we have to find the longest increasing. So you have to maximize. There are multiple increasing subsequences. There are multiple increasing subsequences. We want to maximize the length. So we have a maximization problem. So we'll think in terms of DP, right? So first thing of DP is identifying the state. So let's say f of I or f of n. Let's say f of n. F of n. What is f of n? F of n is the longest increasing subsequence that ends at n. F of n is the longest increasing subsequence that ends at n. That means, let's say this is the nth element. What is the longest increasing subsequence that will contain the nth element a of n as the last element? What is the longest increasing subsequence that will contain the nth element as the last element, right? So for example, let's take an example, right? So let's say we have an array like this: 2, 1, 5, 3, 6, 4, 6, something like this, right? So let's consider this index 4. This index, that is 0, 1, 2, 3, 4, 5, or 1, 2, 3, 4, 5, 6. So what is f of 6? It is the longest increasing subsequence that ends at nth index. So what is the longest increasing subsequence that has this 4 as the last element? longest increasing subsequence that has this 4 as the last element. Now whenever 4 is at the last element, that means, and we are talking about a subsequence, so the previous element should be before 4. So what is the longest increasing subsequence? It can be 3 comma 1 or 2. This is the longest increasing subsequence, so the length will be 3, right? F of 6, the length will be 3. The longest increasing subsequence that has 4 as the last element. So this is the definition of the function, what the function returns, right? F of n. The second is make an assumption. Again, we are skipping this step. We are just assuming that, like, let's make an assumption that f of n doesn't return the value correctly for n equals to n. For every other value, n minus 1, n plus 1, n plus 2, everything, it returns the value correctly. So that's the assumption step. Third step is calculation of f of n. Calculating f of n. So calculating f of n, how do we calculate? Okay. How do we calculate f of n, right? That's what we want to do. Let's see. What is f of n again? What is the longest increasing subsequence? Let's say these are array of characters and this is the nth character, a of n. What is the longest increasing subsequence that ends at n? Now, what can be the previous element? Anything on the left hand side? If there is some, let's say, a of j, there is some j such that a of j is less than a of n. A of j is less than a of n. So the previous element to a of n is the last element, right? A of n is the last element. The previous element to a of n can be a of j if it is less than that. So for every such element, so f of n, how do we find this? For every such element, right? So we want the maximum, we want the, not the minimum, we want the maximum, longest increasing subsequence. So maximum of, let's say the previous element is a of j. So maximum of f of j plus 1. Why f of j? What is the longest increasing subsequence up to j? Up to a of j, what is the longest increasing subsequence? And after that we are adding one more element, that is ending at a of j. Ending at a of j, what is the longest increasing subsequence? And to that we add a plus 1, because we are adding this a of n to this a of j, and this is from j equals to 1 to n minus 1, right? For every j from 1 to n minus 1, it is f of n is max of f of j plus 1 if a of j is less than a of n. If a of j is less than a of n. If a of j is less than a of n, right? So for example, if we take our example again, like let's say there is some array. Let's take some array here. 1, 4, 2, 3, 6, 5, 6, 8, something like this, right? So let's say 5. For this 5 we are calculating, so the last element will be 5. What will be before 5? Something less than 5, and also definitely before 5 occurring. So it can be 3, 2, 1. So it can be either 3, it can be this 2, 4, 1. So 3, 2, 4, 1 out of them. So what is the longest increasing subsequence ending at 3? What is the longest increasing subsequence ending at 2? 4 and 1. Will calculate these things recursively and will add 1 to that, right? So that is what we are doing here. Now, what is the complexity? If we do a bit of complexity analysis, for every state, for every n, we are running a loop from j equals to 1 to n minus 1, and we are seeing if a of j is less than a of n, and then we are adding f of j plus 1. We are comparing f of j plus 1. So for every I, we are running a loop from 0 to I minus 1. For every I, we are running a loop from 0 to I minus 1. What is the complexity for this? N squared. The complexity for this will be n squared. What is the expected complexity? N log n. The expected complexity is n log n, right? So this is the expected complexity. How do we reduce it to n log n? Let's understand this. So think about how the DP is working. Like when you write an iterative solution, when you are writing the iterative solution, how the DP is working. Everything, like you run a loop like this for I equals to 1, I less than equal to n, I plus 1, I plus plus. So every f of j where j is less than I is computed, right? Every f of j j less than I is computed because you're running an incremental loop. I 0, 1, 2, 3 like this will go, right? So if when we are at 5, I equals to 5, 1, 2, 3, 4 will already be computed, right? So every of them is computed, and out of them, and that's what we need, right? We want the elements on the left hand side only. But what do we want? Additional condition that comes here is a of j should be less than a of n. This is only the additional condition. So we want to store it in, can we store it in such a way that we can find, because these are already calculated, right? These are already calculated. So we need a data structure that will help us find the maximum value. The maximum value before, like for all the f of j's that has been calculated before coming to I, with the condition that a of j should be less than a of I. A of j should be less than a of I. We have to compute the maximum value, or rather we have to, this statement we are modifying it such a way that what is the maximum value of f of j, what is the maximum value of f of j, such that a of j is in the range of 0 to a of I minus 1. This is what we are telling. It is less than I, a of I, that means it is less than equal to a of I minus 1, 0 to a of I minus 1 in this range, and you have to find the maximum value of f of j such that this is satisfied. So we are finding the maximum in a range of elements. In this range, we are finding the maximum. So whenever we find the maximum in a range of elements, what is the data structure that we use? We use a binary index tree or a segment tree. So we can use a segment tree. And how will the segment tree work actually? It will only contain, so we are updating on the, whenever we are calculating a f of I, whenever we calculate a f of I, we update on the segment tree at index a of I with the value f of I, right? With the value f of I. So we are updating as we run the loop. So when we are at I, for every j less than I, only those are available in the segment tree. The greater than I values of f of I are not available in the segment tree. So the segment tree contains the value that we actually need, and out of them we want to filter out the maximum in the range of 0 to a of I minus 1, right? So running this query will take a log n time, so it will be n log n using the segment tree, right? So if you optimize this using the segment tree, we are moving to n log n. So let's actually try to write the code for this quickly. A segment tree or a binary index tree, anything will work, right? So first of all, let's see, a of I is 10 to the power 6. Okay, so we want to create a segment tree, right? We want to create a segment tree. So let's create here vector int segment tree, and first thing that we'll do is void update. We just want update and query, right? We just want the update and query. We just want the update and query methods. So void update. I'm writing an iterative segment tree. In case you don't know about how to write an iterative segment tree, just like Google it up. You'll find some code forces blog around that, and that should be like helping you understand. But you can definitely write a recursive segment tree as well. I'm writing iterative because it will be faster to code it up. So int index, we are updating index with value, some value, and n is the total number of elements. So st of, so idx plus equals to n first we do, then st of idx is equals to val. So this is what we are doing, is we are making an update, a of idx equals to val. We are making an update like this. So that is what we are updating on the segment tree. So for idx greater than 1, idx divided by 2 every time, st of idx divided by 1 is equals to max of st of idx xor 1, right? So this is the update, and query will be, it will return the max from a of l. It will return the max from a of l to a of r minus 1. So int query, int l, int r, int n. Remember, r is exclusive here. A of L to A of r minus 1, it returns the maximum in this range. So for res equals to 0, for L plus equals to n, r plus equals to n, L less than r. Again, don't worry about this. This is just a segmentary code. But it's same as query in a segmentary where you find the maximum in a range, and this is update of a segmentary. You can just replace that with your implementation. If L and 1, res equals to max res st L plus plus. If r is odd, res equals to max of res st minus 1, and return res. So this is the segmentary. Now update function, again, you don't have to worry about this. Just think about this as the segmentary update. This is just the segmentary update method. You can do your own implementation. Just what update you are doing is a of index equals to value. Let's say you are updating your array at index idx with the value val. So this will update the segmentary accordingly, right? So you can write your own implementation, and this is just the query in the range a of L to A of r minus 1. So this is just an iterative implementation. Again, to learn this, just write here like code forces, what is that called, iterative segmentary. Iterative segmentary. If you just search for this efficient and easy segmentary, there's a blog around this. Just read from this blog once, like how this works, and see, like you will see that the code is same, right? The code is kind of same, and the code is same that we have written here. So just read about iterative segmentary and try to understand how it works. So this is nothing but updating our index with value val, point update, and this is a range query a of L to A of r minus 1, right? L to r minus 1. You have to find the maximum of them up to in this range. So code, so segmentary first of all we'll find the maximum value. So max val equals to max element a plus n, and segmentary equals to vector int max val plus 1, and everything is 0 initially. Okay, int dp of n plus 1, dp of 0 equals to 0, for int I equals to 1, I less than equal to n, I plus plus. What is dp of I? Dp of I is what you want to compute. You want the maximum. You want to do a query. What is the range you want to do a query in? You want to do a query in one second, max val plus. Okay, so it should be 2 into max element is there, n elements are there, so 0 to, so max val, let's do it plus equals to 1, and 2 into max val should be 2 into max val. The size of the segmentary should be 2 into max val. Okay, so you want to run a query. What is the range where you want to run a query? You want to find the maximum in the range 0 to a of I minus 1. So a of I minus 1, 0 to a of I minus 1, you want to find the maximum value out of them, and n is the number of elements, so that is max val basically. N will be this. Okay, and after that you have after you have the dpi, this will return the maximum, and you will add 1 to this, 1 plus this query of this thing, dpi will be this. So dp, and you will update now, right? You have to update on the segmentary. What is the index that you will update on? You will update on index a of I. What is the value that you will update? dp of I, and n you have to pass max value, and finally you can return dp of n. So this is the, I think we have to do a of I minus 1 here, right? A of I minus 1, and again a of I minus 1, because we are assuming 1 best index. So now this is giving 3, sorry, this is working fine. Let's test against this as well. 5 8 3 7 9 1. I think there are 1 2 3 6 elements. So let's just run this. Okay, so my output is 1. uh, n space separate integer. Okay, why is it 1? Oh, the answer is not dp of n, rather the answer is not dp of n, it is the max value, right? Whatever is the maximum, because dp of n will contain the maximum longest increasing subsequence that ends with a of n, but it can end anywhere, right? It can end at a of 0 1 2 3 anywhere, so it will be the maximum. So maximum of dp plus n, and that's the answer. So now if we run our custom test case, let's run this. dp plus 1 plus n plus 1 max element. So we want the maximum, right? We want the long, it can end anywhere, so that's why uh, so let's, okay, gives a 3 here, output difference is 3. Why is it giving a 3 here? Let's understand this. So what is 3? Ending at 6 will be 1, ending at 3 will be 1, ending at 7 it will be 2, 3 7 or 6 7 it will be 2, 1 plus 1, ending at 4 it will be 2, 3 7 3 4 only, and ending at 6 it will be 3, 3 4 6, right? It will be 3, ending at 9 it will be 4, 3 4 6 9, it should be 4. Okay, so why did we miss that? dp of update a of I minus 1. Okay, the query range should be 0 to a of I minus 1, right? Minus 1, because we are if we give 0 to a of I minus 1, it is anyways finding the maximum from a of L to a of R minus 1. So anyways, a of, we don't have to do minus 1 because it's anyways doing a minus 1 here, right? Okay, that's the segmentary implementation. So let's, this should work. This is working. So this is the code for this. Again, like segmentary, don't worry about that. This is just point update. This is simple a of idx equals to val, or point update. How do you write a point update in a segmentary? This is again range query in a segmentary, range max query. Like you want to find the maximum in a range in a segmentary. So I've done the iterative implementation, but it's eventually the same thing, right? And yeah, this is the main logic. So dpi you will query in the range 0 to a of I minus 1 minus 1, and it is already taken care here. And out of them, what is the maximum value, and then we'll update the dpi value a of at index a of I minus 1 for the next iteration, right? So that's the code for this. Now this is the longest increasing subsequence. For your homework, try to solve the problem subset sum. So subset sum is like you're given a array of non-negative integers and a sum. Determine if there is a subset whose sum is equals to the given sum. So if there is a subset with the sum 9 here, right? So that's what you have to do. And there is, I think, 5 6 7 5 plus 4 is there. Then yeah, 5 plus 4 is there, right? 4 plus 3 plus 2 is also there. That's also 9. Uh, second question is find the count the number of ways to reach the nth stair. So there are n stairs in front of you, so you can climb either by 1 stair or 2 stairs at a time. What is the minimum number of steps that you need to reach the nth stair, right? Third is stickler thief. So stickler thief is like he will take money from each house, but there's a rule that he can never loot 2 consecutive houses. So what is the maximum money that he can get, right? And fourth is interleaved strings. So you're given strings a b c, find whether c can be formed by interleaving a b. An interleaved string is and t is a configuration such that it creates a new string y from the concatenation of substrings of a and b, y equals to a plus b equals to c. So you have to form c using by interleaving a and b. So these are the problems. Again, for your homework, subset sum, count number of ways to reach the nth tier, stickler thief, and interleaved strings. So try these problems for your homework. And today we have already solved 2 DP problems. I hope this makes sense. Like you have got some idea about how to solve the problems, and you will use a similar approach for all of solving all of these problems. Just follow the steps that I mentioned, and you can easily solve them as well, right? So yep, thank you guys for joining in, and I'll be seeing you on Friday.